Imagine walking onto the floor of a facility so incredibly massive that it literally generates its own internal weather system. You are standing on the very edge of a man-made volcano. This is a modern aluminum smelter, an industrial beast where the heat is so intensely aggressive that it physically warps and distorts the air you breathe. Everything around you in this harsh environment is colossal, deafening, and inherently lethal. But the most terrifying thing in this sprawling multi-million-dollar complex is not the glowing molten metal splashing from the heavy steel crucibles. It is a hidden, completely invisible clock. You see, an aluminum smelter is not like a standard assembly line. It is not a normal factory where floor managers can simply flip a master switch, lock the heavy doors, and send the workforce home for a long holiday weekend. This machine is fundamentally alive. It breathes raw electricity to survive. And it has a fatal vulnerability, a single point of failure that keeps plant directors and engineers awake at night. If the external power grid fails, if the flow of electricity is interrupted for just 4 short hours, this entire facility does not just pause its operations, it dies. It literally freezes from the inside out, rapidly transforming into a solid, impenetrable graveyard of rock and metal, bringing an entire corporation to the brink of absolute financial ruin. If you are enjoying our channel, subscribe and turn on the little bell so you don't miss any content. It helps us a lot, and it's free. To understand why a simple blackout is a literal death sentence for a heavy smelter, we first have to expose a massive industrial illusion. When you think of heavy metallurgy and melting metal, your mind probably goes straight to a traditional steel mill. You picture giant blast furnaces roaring with open flames, mountains of burning coal, or high-pressure gas jets melting everything in their destructive path. But look closely around this facility. There is absolutely no fire here. The secret behind the lightweight aluminum in your smartphone chassis, your car engine, and the commercial airplane you fly in is a continuous, violently unstable electrical storm. It is a chemical miracle known as the Hall-Héroult process. Inside this heavily guarded factory floor, there are endless lines of massive steel vats called pots. These pot lines can stretch for literal miles inside a single building, requiring intense security perimeters and strict operational protocols just to maintain safely. Inside every single one of these heavily engineered vats is a highly reactive, incredibly toxic chemical bath of molten cryolite and alumina, constantly bubbling and churning at nearly 1,000 degrees Celsius. But what keeps this hellish soup boiling if there is no fire to be found anywhere in the building? The answer is pure, unadulterated electrical current. Hundreds of thousands of amps of electricity are continuously pumped directly through the liquid bath. To put that extreme volume of energy into perspective, the main circuit breaker in your house might trip at 20 or 30 amps to prevent a structural fire. These industrial pots are running on anywhere from 300,000 to 500,000 amps. The magnetic fields generated in this room are so intensely powerful, they can literally rip a heavy steel wrench right out of a maintenance worker's hand if they violate the strict safety zones. The electricity itself is the heat. It acts as the very blood of the factory. The immense electrical resistance of the chemical bath against that massive current creates the blistering temperatures needed to separate pure liquid aluminum. As long as the current flows uninterrupted, the metal stays liquid, pooling at the bottom of the vat to be harvested daily. The entire factory hums in a state of extreme volatile balance. Now, think about what happens when that fragile balance is violently shattered. What happens when a severe winter storm takes down a critical transmission tower, or a cascading system failure causes the local power grid to collapse under peak demand? In a split second, the deafening, bone-rattling hum of the pot lines goes dead silent. The heavy industrial lights flicker and instantly die. The massive ventilation fans that keep the toxic fumes at bay begin to spin down to a heavy halt. And in the pitch black of the factory floor, the workers do not scream, they do not panic. They just know that the invisible countdown has officially begun. Minute by minute, the core temperature of that 1,000-degree chemical bath begins to drop. It is a brutal, unforgiving race against the laws of thermodynamics, and physics has absolutely no mercy. The atmosphere inside the plant changes in a matter of minutes. Without the massive exhaust systems pulling the suffocating heat and chemical fumes away, the air becomes incredibly thick and heavy. The workers must scramble in the dark, armed only with flashlights and heavy battery-powered emergency gear, fighting against an atmosphere that is rapidly cooling. Their singular, desperate goal is to manually siphon out as much molten aluminum from the pots as humanly possible before the temperature drops too low. Faced with a machine that defies physics but can turn into a concrete graveyard in hours, What would you have done in the place of these workers? Leave me your opinion in the comments, because the decision they have to make next changes everything. But this intense struggle in the dark is still not the heaviest part. What comes next seems absurd, but it is entirely real. The 4-hour mark is rapidly approaching, the temperature is plunging, and the true nightmare of the frozen metal is just about to be revealed. As the digital clocks in the dead facility cross the 4-hour threshold, an eerie, almost imperceptible shift occurs deep inside the hundreds of steel pots. The ambient heat that the workers have been desperately fighting to preserve finally loses its battle against the creeping cold of the unpowered factory floor. What happens next is a violent, irreversible betrayal by the laws of chemistry. The toxic bath of cryolite, alumina, and pure liquid aluminum stops behaving like a fluid. It begins a fatal phase change. The intense, hellish soup starts to crystallize. As it drops below its critical freezing point of around 950 degrees Celsius, the entire mass begins to solidify. But it does not just harden gracefully. It begins to thermally contract and then aggressively expand as the chemical structure changes, locking its crystalline fingers into every microscopic pore of the highly engineered carbon lining. It violently bites into the heavy steel shell of the crucibles. In a matter of minutes, the high-tech chemical reactors that form the very heartbeat of this multi-million-dollar industrial complex undergo brain death. They transform into solid, immovable blocks of artificial rock. Each of these frozen blocks now weighs dozens of tons. The entire factory, which just hours ago was a roaring, humming marvel of modern engineering, has silently flatlined into a sprawling, frozen graveyard. You might be sitting there wondering why they cannot just wait for the local power grid to be repaired, throw the massive master switches, and simply melt the whole frozen mess all over again. That is the most brutal and deceptive part of the aluminum trap. It is the secret that bankrupts corporations. You cannot just hit the restart button. The electricity in the Hall-Héroult process absolutely requires a highly conductive liquid path to flow smoothly from the giant carbon anodes down to the cathode lining at the bottom. When that molten bath turns into solid rock, it fundamentally changes its physical properties. It becomes a massive, stubborn electrical insulator. The conductive circuit is completely and permanently broken. If a desperate plant manager were foolish enough to try and pump 300,000 amps of raw electrical current into a frozen potline, the electricity would have nowhere to safely go. It would violently arc through the air, completely destroying the multi-million-dollar electrical busbars, vaporizing equipment, and potentially causing catastrophic, lethal explosions. The circuit is dead forever. The machine has chosen to die, and there is absolutely no electronic defibrillator big enough to bring it back. The reality of fixing this monumental industrial disaster is something the clean, modern tech industry rarely ever shows you on television. It is a brutal, agonizing, and almost medieval process of resurrection. To bring a dead potline back to life, you cannot rely on elegant engineering or software updates. You have to rely on brute, devastating physical force. Specialized demolition crews have to be brought into the facility. They march into the silent factory armed with heavy pneumatic jackhammers, massive industrial excavators equipped with hydraulic breakers, and sometimes, in the most severe cases of fused rock, they literally have to drill holes and use targeted dynamite inside a closed building just to break the solid metal and carbon apart. They have to violently, methodically destroy the interior of every single ruined furnace. They spend weeks ripping out the fused carbon blocks, the shattered refractory bricks, and the warped steel shells. Once the carcasses of the dead pots are entirely hollowed out, they have to rebuild them entirely from scratch. Every single component must be remanufactured, baked, and reinstalled. We are talking about long, grueling months of agonizing, back-breaking labor in incredibly hazardous conditions. The financial hemorrhage during this period is absolutely staggering. You are not just looking at the cost of physical repairs, which can easily run into the tens of millions of dollars. You are looking at the catastrophic loss of daily production. Every single day that factory stays dead, the company bleeds money. A single poorly timed 4-hour blackout can effortlessly erase an entire year of profit for a massive multinational corporation. It is a level of financial devastation that can collapse local economies and put thousands of heavy industry workers out of a job overnight. This brutal reality forces you to look at our modern high-tech world completely differently. We like to believe that we have conquered nature, that we have built towering, invincible empires of glass and metal, and that we have engineered machines that are practically permanent. But all of this monumental industrial might balances on the incredibly fragile, razor-thin edge of a copper wire. It all depends on an unbroken, invisible stream of electrons flowing from a power plant miles away. The next time you grab a cold soda from the fridge, or hold a lightweight piece of aluminum in your hands, or step onto an airplane, I want you to think about the extreme, volatile, and deeply unforgiving environment that metal came from. Think about the heavy, suffocating tension that hangs over the factory floor every single day, and have a profound respect for the dedicated workers who stand shoulder to shoulder beside a colossal beast of a machine. A machine that is incredibly powerful, absolutely essential to human progress, but one that, if left alone in the dark for just a few short hours, will stubbornly choose to die and drag the entire empire down into the abyss with it.